Okay, so I'm going to do a system overview, how to access, how to get account access, how to log in, how to set up your GroqFlow environment, which we've already seen, and how to use PBS to run a few samples. You've seen a better picture of this in a previous presentation, but this is the hierarchy. We have one GroqRack, 9 servers, 8 cards, or Groq cards per server node, and each card has 1 chip. And there's also an additional controller node that you can't actually log into as a user. First thing you need to do, if you don't already have one, and many people here do, is request an ALCF account. You'll have access to these PDFs, but the links here are clickable. It's accounts.alcf.anl.gov. Once you have an account, then you log in here using the login panel that you're seeing. And the menus on the left will change. You can join a project. You want to join the Groq training project. And you want to then also, I'm not sure how long that joining process takes because I only did it once, but you'll want to check under the request and view systems for Groq in the list of systems that you have access to. Once all of that is looking good, then you can log in. The system, like the other ALCF systems, is set up with a few login nodes as the front end, and then the system itself is behind the login nodes. So you log into Groq login 01 or 02 using your ALCF user ID and a MoldPass passcode. Once you've done that, your authentication is done. You don't have to deal with that anymore, and you can log into one of the Groq nodes. There's 9 of them, and they're GN 0. Well, they're 1 through 9. So you saw a live demo of Conda install earlier, mini Conda install. I always take the, and if you haven't done that in the ALCF home directory, you're probably going to have to do that. And I find it best to just answer yes or whatever to all of the prompts, but that's your choice. Create a GroqFlow con environment and activate it. This is the version of Python that we're recommending to use with the currently installed version, and activate it. And then install GroqFlow. I think you saw this as well. You want to clone, and these are you want to clone the GroqFlow repo, and then you're doing making sure that the environment is activated. You're doing a pip install on a couple of directories inside of the GroqFlow to install the GroqFlow and the demo helpers. The workflow that you're using is through PBS. So you're using PBS Workload Manager and Job Scheduler that's used on some of the other ALCF systems. Well, this is the first testbed system that we're using it on. The GroqFlow framework, again, you saw this earlier, combines compilation and execution, compiles a cache there. Compile artifacts are in those cachers. You can also do steps manually. You can see the steps. You've seen this earlier. So I'm going to show batch mode and interactive mode. In batch mode, you need to create a PBS batch script, and it looks like following. You can copy paste this from the PDF if you need to. The section at the top is because you're getting a a non-interactive environment, so you need to initialize conda typically. And that's just copied from my bash RC, literally copy pasted from my bash RC. And then the steps for actually running, which consist of making sure your conda, your GroqFlow environment is active, changing to your working directory, making sure requirements are installed, and doing a Python, doing the Python command to launch your model script. And that's the script. To run the script under PBS, you want to do this. You're doing a Q sub, you're specifying that you want n accelerators. This model only needs one, but I'm giving it two. And then a script name, and the output by default will go to two files in the current directory, and they look like the following: the script name dot error or output, and then the job, not the job ID. So running a sample in PBS and in interactive mode might be more friendly to people, because you can see the output right away. So to do that, you do you do a command that looks like this in the Groq environment. In this case, you're specifying a 24-hour PBS session, interactive session. Once you've done that, inside of that environment, you activate your GroqFlow and then do the usual steps. You're changing to the working directory, doing a pip install requirements.txt, because the various samples that are included in the GroqFlow sample directory are, have their own requirements files, and running it. The number of chips is determined during the compile phase. I found the value in this location in the cacher. You can do that too. Basically, there's a state.yaml in the cacher for the model that you're using that has this string in it, and that will tell you how many chips you need to reserve. Let's see. That's pretty much it. Utility commands. You're going to want to do qstat-w because some of the fields are kind of long. And if you want to delete something, you're going to need the job ID. So you do qdelete and then the job ID to delete the job. The GroqFlow repo, we've seen that a few times already. The AI testbed user guide, we have documentation for the various AI testbed machines, and the GroqFlow one is there. The Groq has some public documentation at their website, including some white papers and spec sheets that you might find interesting. And that's it for the PowerPoint. I was going to show a live demo as well. Okay. I don't know how to access my.
Is Zoom blocking the way?
Yeah.
Oh, we see. Okay,
It's
seeing
blocking
something.
my.
Yeah, I know. A lot of the presenters had to deal with that. Are you trying to go to the terminal?
I have a terminal already here. Let's see.
Oh, there we go.
Somewhere there it is. Yeah. I have a whole bunch of terminals. All right, I'll just. This is very awkward. Okay, I'm gonna have to find a.
No worries.
All right, here's okay.
That's
So
perfect.
I'm going to first SSH to a GroqRack system. I use the -v switch just to debug any SSH problems. And that's strange. I seem to have lost my my mobile pass wasn't on my phone. Oof.
Awesome.
Occasionally our authentication is broken. I was afraid it was happening just now again. All right, so now I've SSH to a GroqRack node. I had a script somewhere. Here we are. So I've already installed the Conda environment, so I have the base environment active here, you can see. So I need to if I was going to be working directly on this node with GroqFlow, I would do Conda and activate on a GroqFlow. I've already cloned the GroqFlow Git. Into my home directory, so I'm not going to do that again. I've already created that script that I showed earlier. That looks like that. So I'm just going to run it. And you can see the job started. I can do a qstat -w and I can see the job running. This particular job I've been finding takes about 2 minutes. So I'm going to just show the previous results. The warnings are because we have some package installed that requires that the app sources directory be locked from users. I wasn't able to talk our admins out of that, so you can ignore those. The regular execution looks like this for the GroqFlow samples. Let me shrink that down. You can see the requirements installed. Because I've already run this, it's found the model in the cache, and it's going to run quickly the second or nth time. The GroqFlow proof point samples all show a CPU run and a Groq run, and they show latency and IPS and the like, and when you can see the speed difference, the Groq latency tends to be really low. So that's the sample running. Let's see. Yeah, it still hasn't completed. Yeah, it'll complete in another 40 seconds or so. So interactive is a little more straightforward. The command that you're using is that. It takes, I don't know, maybe 10 seconds to give you a prompt. You have the base and kind of environment there, but you need to activate your GroqFlow environment. All samples are in a proof points. Well, some of the samples are in an example stir. Most of the samples are in the proof points, and I'm going to show one of them. I've already installed the requirements previously, but I'm going to do it again just to reinforce that that needs to be done. And then running a sample at this point in the proof points directory looks like this. And they all pretty much look the same because they're in the same framework. It found it in the cache stir. The Groq inference runs with no progress indicator, and it runs very quickly. And then the inference using CPU is slower. And yeah. And I did show what the output looks like, so I'm going to stop this. When you're done with the PBS interactive job, you can just wait for 24 hours and it'll go away, but you can also exit it. And so that's how to run a job in batch mode and how to run a job in interactive mode. Sanjeev covered a whole lot of details earlier on the actual goings on, but that's it. That's it for my demo.